Hey, welcome to Night Club. Today we're doing lesson 4-6, rational equations and partial fractions. Now, again, I got rational highlighted because that means what?
Ratio.
Which means fractions. So anytime you see rational, we're going to be dealing with fractions, okay? So we're solving this fraction equation, rational equation. I solve it by getting rid of the fractions. So here's what you do to get rid of the fractions. You multiply by the common denominator, all right? So before I can figure that out, I need to do a little factoring. So right here, x squared minus 1, I can factor that to be x plus 1, x minus 1, okay? Did I say x?
Yeah.
How did I say x and write a? I'm talented.
Good.
That's it. All right. So, a plus 1, a minus 1. This is that denominator. This denominator is a plus 1. What's the denominator on this one? Nope. It's just 1. Okay? It's just 1. So, what would the common denominator be? All I have to do is take all the denominators and what? Combine them, which is basically these two. Okay? So, I'm going to multiply everything, each term, by a plus 1 times a minus 1. So I'm going to multiply this one by a plus 1, a minus 1. Guys, shh. A plus 1, a minus 1, and multiply this one by a plus 1, a minus 1. Okay? Now, when I do that, on this first one, there's no denominator, so nothing cancels. I'm just left with a times a plus 1, a minus 1. Plus, the plus comes from here, okay? Plus, what cancels? Both of them. A plus 1 cancels, and a minus 1 cancels, and what am I left with? A squared minus 5 equals. On the right side of the equals, what cancels? A plus 1. So I'm left with a squared plus a plus 2 times a minus 1. And now, no more fractions. Okay?
Wait, go on.
No problem. You do. You have to multiply, FOIL, and multiply it out, and get a's by itself, and solve it. Okay? So, I've already, you can do it all if you want to, but you already know what that equals because you factored it right here, okay? So if I multiplied it out, what am I going to get? A squared minus 1. So this is a times a squared minus 1 plus a squared minus 5 equals, here I'd have a squared times a is a cubed. A squared times negative 1 is negative a squared. A times a is positive a squared. A times negative 1 is negative a. 2 times a is positive 2a. And 2 times negative 1 is negative 2. Okay? One more thing I need to multiply out right here. Distribute your a in the front here, so that's a cubed minus a plus a squared minus 5 equals, on this side I got a few things I can add up. So a cubed, negative a squared, and positive a squared make 0. So they go away. What's negative a plus 2a? Positive a, and then minus 2. And now we get all our a's on one side, set it equal to 0, and solve it. So, if I subtract my a cubes, what's going to happen? They also cancel. That's a good thing, because solving quadratics is way easier than solving cubics. Move my a over, and my 2 over. And I'm going to write this in the right order. So what should come first over here on the left? A squared minus 2a minus 3 equals 0. And at this point, you can factor quadratic formula, complete the square, however you want to do it from the last chapter, okay? Can I factor it? Factoring is usually the easiest if it's being able to factor, okay? So what two numbers multiply to be -3?
Negative 3 and 1.
And add up to -2?
Negative 3 and 1.
-3 and 1. So A equals 3, and A equals -1, okay? Now,
Wow.
you should do this every time you solve an equation, but especially when you're doing rational equations, because sometimes the answers you get cause problems. So, if you were to plug it into the original, those three answers, okay? If I plugged in 3, would I have any problems in the denominator? Would I get 0?
No.
Not for 3, but what if I plugged in -1? Yes. So guess what -1 can't be? It can't be an answer.
Oh.
Okay?
Not 0.
It's called an extraneous solution, which just means it's an extra solution that works on paper, but it doesn't work when you go to plug it in. Does that make sense? Okay? Because if I plug -1 into the original problem, I get 0 on the bottom of my fraction in the denominator, and you cannot divide by 0. Okay? Everybody good? Yes, sir. Simeon.
Where'd you get -2?
Here, -a minus a. When I moved, I had a positive a over here. I subtracted it over, and there was already a -a over here. So -a minus a, -2a. Just add the like terms. Okay?
I'm not gonna lie. I have no idea what you did. I was
Can you go a
writing
little
it
bit
down.
slower? Yeah, can you go slower when you do that?
You were just.
We'll do it again in a minute.
I was just writing it down.
Everybody good? The next, example 2. Okay? Or it's actually example 3, but it's our second one. If it will go to the next slide. There it is. Okay? And we're going to do what we just did on this one, so that's why I'm just going to use this example to get another practice run. But I want you to understand what you're doing. It says decompose this into partial fractions. So I'm actually, and you don't have to write what I'm about to write down if you don't want to. You don't have to write it. You can just watch. But I'm going to go the opposite direction. I'm going to show you the answer and get this. Okay? So here's what we're doing. This is the answer. Okay? This is what we're going to get when we solve that problem. But here's what you're doing. How do we add these? What do we have to get? A common denominator, which would be just the combination of these two what? Together, right? Y minus 1 times y plus 2. Everybody understand that? So, what is this one missing on the first one, on the bottom? So I'm going to put a y plus 2 here, but I also have to put one where? On the top. Y plus 2 on top. Everybody with me so far? What's the bottom one missing? Y minus 1. So if I put 1 on the bottom, I also have to put what? 1 on top. You're doing the same thing as if you were just adding 1/6 plus 1/7. Okay? What's the common denominator? 42. But how did you get 42? You multiplied 6 times what? 7. So you would do a 7 on the bottom, 7 on top, 6 on the top, 6 on the bottom. That's the same thing we're doing here. It's just with variables. Everybody good? Okay? And then you add that up. Like over here, if we kept going, now we have 42 on the bottom, correct? But on top, we've got 7 plus what? 6. So it'd be 13 over 42. We're going to do that here. So now on the bottom, we know we got y plus 2, y minus 1. But on top, what's 5 times y? 5y. 5 times 2 is 10. Plus 3 times y, 3y. And 3 times 1.
It's supposed to be a negative 1.
Is it?
So it's negative.
Thank you. Sure is. I put it on the bottom, didn't put it on the top, though. Silly boy. Thank you for keeping me straight. Okay? So my final answer would be 5y plus 3y is 8y. 10 minus 3 is 7. If I multiplied that out, that would be what? Y squared. I'm going to get negative y plus 2y. What is negative y plus 2y? Plus y minus 2. Okay? So I did all that to understand. The partial fractions is what you had to begin with, and you combine the fractions to get this. So what we're doing is we're starting with that, and they want us to work backwards to get what were the partial fractions. Okay? So everything we just did, we're going to do in reverse. Okay? So what was our last thing? We FOILed that, right? Okay? So on our problem, when it says decompose into partial fractions, we got to figure out what's the denominators on the two partial fractions, which is just means we just do what to that? Factor it. Okay? So I know it's going to be 8y plus 7 over y plus 2, y minus 1. Okay? I factored the bottom. These are the denominators of my two fractions. So I'm just going to write them down. Y plus 2 plus something, y minus 1. Now, do we know the numerators right now as we're talking?
No.
No. That's what we're looking for. Okay? So I'm just going to let the numerator for this one be A, and the numerator for this one be B. And we're going to solve it for A and B. Okay? How do we solve it? We solve it just like we did on the first example we did. Okay? We're going to have to multiply the entire rational equation by the what? Common denominator, which would be right here. These two combined. Okay? So everything up here, I'm going to multiply by y plus 2, y minus 1. Okay? Same thing here. Y plus 2, y minus 1, y plus 2, y minus 1. You take whatever your common denominator is and multiply everything by that common denominator. Okay? Why are we doing it? What's going to happen next step? All of the fractions will go away. Okay? So on the left side, the y plus 2's what? Cancel. Y minus 1, cancel. I feel like that TikTok where the chick had, see this? Couldn't wear it. Couldn't wear it. Okay? So, cancel. Cancel. All right? Y plus 2, cancel. All right? Y minus 1, cancel. So I'm left with 8y plus 7 equals A times y minus 1 plus B times y plus 2. Bye-bye fractions. Okay? Now the rest of it's actually pretty easy.
You had me confused on the first one.
Well, this is the first one you've seen. So we're going to do this twice because how many variables am I looking for? 2. I'm looking for A and B. Okay? So take them one at a time. I need to get rid of one of them. Okay? So if I'm getting rid of, we'll find A first. If I want to get rid of B, what could I let Y be that would get rid of B?
Negative.
Negative what? Negative 2. Because what's negative 2 plus 2?
0.
And 0 times B? 0. Gone. Okay? So, I'm going to let over here Y be negative 2. And I'm going to plug in negative 2 in the rest of the equation. So, 8 times negative 2 plus 7 will equal A times negative 2 minus 1. I plugged it in the B part, but what happens to it? It goes away, so I'm not bothering writing it. Everybody with me? That will leave me negative 16 plus 7, negative 9, correct? I think that's right. Negative 2 and negative 1 make negative 3A, and then we divide by negative 3, so 3, A equals 3. All right, what do you think we're going to let Y be to get B? 1. And I do the same thing. But now I'm getting rid of the A. Because what's 1 minus 1? 0, so that would go away. Plug in 1 for the rest of it. So 8 times 1 plus 7 equals B times 1 plus 2. What is 8 plus 7? 15 equals 3B divided by 3. B equals 5. So my last step is to write down my partial fractions. So A, 3, over, what was A over? Was it y plus 2?
Yes.
Yes. A was over y plus 2. So 3 over y plus 2 plus, what's B? 5 over y minus 1. There are my partial fractions.
Here you go.
I sure can. Now that seems like a really long thing, but I think it's just because I showed you the other way first. Okay, so remember, you don't have to do that. I was just showing that so you'd understand what you were doing. Okay, so the other way, we started with this and combined them, and we ended up with our problem. Now we're just doing the opposite. Okay, everybody good? Awesome. All right, hold on, wait. I'll hold on, wait. All right, example 4, which like I said will be our third example because we skipped example 1. It says solve, and it's just another rational equation, but this time it's a inequality. Okay, so we want it to have 0 over here because that makes things a little easier. I sure can. You have to find a few numbers because what's going to happen is we're going to have a certain number of x's that we're going to deal with, and we're going to have to talk about their intervals. And so that may not make sense right now, but hopefully it will after we do this. So the first x's that you need to figure out is we talked about asymptotes before, right? Okay. What x can't be. So what can x not be? Can't be 3,
It'd be less.
and it can't be 4. Because that would give us what in the denominator? 0. Okay? So x equals 3 and x equals 4 are 2 of the numbers we need. All right? If I were actually working it out and I wanted it, forget the inequality sign, I wanted it to be equal to 0, what would my answers be?
2 and 1.
Very good. You just make the top be what? 0. So x equals 2, x equals 1. So those are my numbers that I'm checking. Okay? But you're not checking those actual numbers. All right? Because, again, we're talking about less than. So think of a number line, and these 4 numbers are going to be on it. 1, 2, 3, 4. Okay? Between those are the intervals that we're going to check. So how many intervals do I have? 5. Okay? The first interval is going to be when x is what? 1. X can be less than 1. X can come between 1 and 2. X can come between 2 and 3. X can come between 3 and 4. And x could be greater than 4. These are my possible answers to that inequality. So now we just have to plug in numbers and see which ones work. Okay? Now, when it's like this, sometimes you have to worry about getting the exact answer, and sometimes you don't. And you'll see what I mean here. On this one, we don't actually need to worry about the exact answer. We just need to know, is this number on the left going to be negative or is it going to be positive? Because it has to be less than what? 0. So if it's a negative number, is that true? All negatives would be less than 0, right? If it's a positive number, we know that that's not true, that that's not going to work. Okay? So we're going to plug in 5 different numbers, 1 from each interval, and see if it works. Okay? And again, plugging in the whole number is kind of a miss. We are plugging it in, but I don't care really what the number is. I just care whether it's positive or negative. Okay? So I'm going to try. What's a number less than 1. I'm going to go 0. Just makes it easy. Okay? So x equals 0. Could I have picked 0.5? Absolutely. Okay? I'm seeing which of these it is. Okay? So 0 is less than 1, correct? So I'm going to try 0. If I plug 0 in here, what kind of number would I get? So negative times, if I plugged it in there, what kind of number would I get? Divided by negative again, negative squared. Okay? Well, negative squared becomes a what? A positive. So I end up with a negative times a negative on top is a positive divided by a negative. And what's positive divided by negative? It is equal to a negative. So would that one work? Yes. Because if I get a negative number, it's going to be less than 0. Everybody see how I did that? Okay? I didn't really care that 0 minus 2 was negative 2. All I cared about was it being negative. Everybody with me? All right. What's the number between 1 and 2? 1.5 works for me. Just split the difference. All right. Same process. I'm going to plug it in, see what kind of numbers I'm getting. 1.5 minus 2 is negative. 1.5 minus 1. 1.5 minus 3. 1.5 minus 4. Negative. Simplify it. Negative squared again would be what? Positive. So I end up with a negative divided by a negative. Negative times a positive. So negative and a negative make a positive number. Negative divided by negative would be a positive. So does that one work? No. So that one doesn't work.
So you're trying to make it negative?
I'm trying to make it negative because if it's negative, it is less than 0. Now, if that inequality was greater, then I'd be trying to make it what? Positive. Because now if it's negative, it's not greater than 0. Okay? So it all depends on what your sign is. All right? What's the number between 2 and 3? 2.5. So here we go again. On my own. Going down the only street I've ever known. I'm just glad somebody knew it, Jacob. It's a bunch of young kids.
Because I actually have class.
You were picking up. You actually have class. You were picking up what I was putting down, and I appreciate that. That's a song, people.
I was saving what you were putting down.
There you go. All right. If I plug in 2.5, to 2.5 minus 2, positive or negative? Positive. 2.5 minus 1? Positive. 2.5 minus 3? Negative. 2.5 minus 4? Negative, but again, negative is being squared, so it becomes what? Positive. So I end up with a positive over a negative, which would give me a negative. So that one also works. Okay, so we got 2 answers so far. What's something between 3 and 4? 3.5.
Can you use this? Can't you use that one and the next one? Or no?
Can I, what now? What?
The 3.5, can it be for?
No, because the next one I would need something greater than 4.
Oh, great.
Yeah. All right, 3.5 plugged in on top. I get 2 what? 2 positives. On the bottom, there I get a positive. There I get a what? Negative, but it's being squared, so it also becomes what? Positive, so that would be a positive, so that's going to be a no. And last but not least, something greater than 4, I'm just going to use 5. We use 17 in first block just to be fun. It doesn't matter. That's going to be positive, 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 and positive squared, so it's also positive. So that one does not work either. So my answers are x is less than 1, and x has to come between 2 and 3. 2 is less than or equal, or less than x, which is less than 3. Okay?
This is really time-consuming.
It very much is. Now, I said it very much. She said it's time consuming. I have good news. Not all of your problems will have this many numbers to worry about. Because the fewer the numbers, the fewer the intervals. You got me? Okay? So don't get freaked out too much. Plus, you only have like 10 total questions, so it's not too much. Yes, sir?
What if it was less than or equal to?
It's less than or equal to, then you would put equal to. Okay. So let's say here, we just put equal to. Everything would stay the same, but now you have equal. Okay. Last example. One more. Same type problem. This one's not as long. You're welcome. Okay. I'm sorry. I need to go back.
Yeah. Which one were the answers? Which one was the answer?
X is less than 1. 2 is less than x, which is less than 3. Those are your actual answers.
I didn't know you had to make them into equalities.
I'm sorry?
I didn't know you had to make them into equalities.
Inequalities?
Inequalities.
Yes.
Equalities.
All right. Last example. Same process. I'm going to solve it first. Okay? 2 over 3a plus 5 over 6a. What would make that equal 3/4?
18.
Okay? Now, actually, I said I was going to solve it first. I'm not. What can we not use for a? 0. Okay? So there's one number that I know I'm going to have on my number line. Okay? I can't use 0 because that would give me what down here? Zeros in the denominator. Okay? So that's going to be one number on my number line. Let's solve it. This one's actually an easier one. What's my common denominator? More? 12. Somebody said it. Will 12 go in? Will 3 go into 12?
Yes.
Will 6 go into 12?
Yes.
Will 4 go into 12?
Yes.
Yes. Now, you say 12, but it's also 12 what? A.
Wait,
So-
why can't it be 0? I thought it had to be greater than 3.
I'm talking about it can't be 0 because you would be dividing by 0. Okay?
And it just gives you 0.
Correct. No, it doesn't give, it gives you undefined because you can't divide by 0. You can never divide by 0.
Did you multiply the 3 and 4?
I did. You can think of it like that, Caitlin, or just think, what's the smallest number that all 3 of these numbers will go into? Okay? Because I want you to understand, it's 12a, that is the common denominator, but that's not the only common denominator. If I had done 24a, that would have been good too. My numbers would be a little bigger. But 24a, I would still work it. It'd still work out to be the same answer. Okay?
Are you dividing 3 by, multiplying 3 and 4 by, or just 3/4 by 12a?
I'm multiplying every term up here by 12a.
So just 3.
This term, and this term, all by 12a. Oh, yes. Yeah, just the tops.
Yeah.
Yes. All right. So what's 2 times 12a? 24a divided by 3a. 8 by fraction. Plus 5 times 12a is 60a divided by 6a is 10 by fraction.
Why don't you bring the a?
Because the a is what?
Oh.
The a is canceling. Now it doesn't cancel here. What's 36a divided by 4? 9a. Okay? So how do I get the a by itself? Divide by 9. What is 18 divided by 9? 2. So on the last problem, we had 4 numbers. This one we only got what? 2. That means my math's going to be a lot quicker. Okay? So for my number line, I got to worry about 0 and 2.
Oh, we have to make a number line too? What's it?
Yes,
Is it
ma'am.
required?
To look at, you don't have to, but I do it so I'm seeing the intervals. Okay? So what was it again? 2 over 3a plus 5 over 6a, and I need it to be less than or greater? Greater than 3/4? Okay. So I need a number that's a is less than 0, 0 is less than a but less than 2, and I need a number greater than 2. Those are my three intervals that I'm checking. Okay?
So how do you know when to do those numbers? Like, what numbers?
Every time these numbers are a combination of your solutions and what your variable can't be. So like on the first one like this we did, it goes back, there it is. They couldn't be 3 and 4 because 3 and 4 would give you 0 on the bottom. But to answer the question, we needed it to equal 0. 2 and 1 gave me 0. So these first two were the ones that really X can't be those. And these are what the answers are, 1 and 2. But you use all 4 of those numbers to make your intervals. So on this problem, we don't have 4 numbers, we just have 2 numbers, okay? It can't be 0, and the answer is 2. So those are the 2 that we use to make our intervals.
Do you want it to be positive or negative?
We want it to be greater than 3/4 this time. So like last one, we just did positive and negative because it was 0 over there. You can't do that on this one because what's over here now? 3/4. So now we actually have to do a little more figuring. It's not much.
You actually have to plug
Okay,
it in.
you actually got to plug it in. So what's a number less than 0?
-1.
So if a equaled -1, I would have 2 over what? -3 plus 5 over -6. Is that going to be greater than 3/4? Well, common sense tells me if I add 2 negative fractions, is there any way it's going to be positive? No, so that one does not work. See how I did that? Okay? What's something in between 0 and 2? So if I plug in 1, I'm going to have 2 over 3 plus 5 over 6. Is that greater than 3/4?
Yes.
Well, 5 over 6 by itself is bigger than 3/4, and I'm adding to it, so that means yes. So that one would work. So there's one answer. 0 has to be less than a, which is less than 2. And let's try, what's something bigger than 2? 3. So that would be 2 over 9 plus 5 over 18. Is that going to be greater than 3/4?
No.
I don't think it is. I think you get 1/2. Is 1/2 bigger than 3/4?
No.
It is not. So the only answer we have on that one is 0 is less than a, which is less than 2. All right? Hope this video lesson helps you out. Spread the word. Tell your friends. Hope you have a great day. See you next time. And as always, stay above the line.